Well, now we're on recording 2, and recording 2 on page 2 of your results section actually gives you all the answers to what we basically did. What I basically did with this analysis is I took the data and put it into an SPSS program. What I would ask you to simply do with this particular page is annotate it. Really try to write everything down of what every number means, where we get all these numbers from, because then you're going to be asked to do a couple of these on your own. You won't be asked to compute everything, but you'll be asked, if I give you certain information, can you fill in the rest of the table? So let's take a look at this. 1, 2, 3 versus 5, 6, 7. So if I look at my group statistics here, it says group 1, it says drug, and group 1, notice N. What does N stand for? That is the sample within each group. So group 1 has 3 people, and so does group 2. Let's look at the next column, mean. Can you figure out the means there? The mean of the first group is 2. The mean of the second group is 6. Hopefully that's pretty easy to figure out. You just add the scores up and you get the mean. Notice that for all these situations, I'm not going to use really any Greek letters. Why am I not going to use any Greek letters here? These are all samples, right? I'm only using the sample, so I really don't know much about the population. Can you figure out how each one of these computer programs got a standard deviation of 1 for each data set? Well, hopefully what you would be able to do, and you should write this out, any 3 consecutive numbers, think of what you need to do first. You need to get the sums of squares. So 1 minus 2 plus 2, 1 minus 2 squared plus 2 minus 2 squared plus 3 minus 2 squared. That equals 2. How do you go from sums of squares to variance? You divide it by n minus 1. So it's 2 divided by 2. So the variance is 1 and the standard deviation is 1 as well. So the standard deviation of any 3 consecutive numbers for a sample, standard D is 1. Can you figure out how they got the standard error of the mean? Think about that from last week. How do you go from standard D to standard error of the mean? The formula for that, the standard error of the mean equals the standard D divided by the square root of n. So you take 1 divided by the square root of 3, and hopefully you get 0.57. You can lay it right down on the line that if you ever get 3 consecutive numbers, you can know the standard deviation is 1 and the standard error of the mean in these group statistics is also 0.57. So hopefully that makes sense to you, the top table. Hopefully you can annotate this, which is what we're hoping for. Now let's go down to the bottom table. The bottom table is the new stuff, if you will. The nice thing about these computer programs is that they actually give you everything you need. You just have to figure out what they're saying. So to begin the bottom part of the table here, let's actually look at that column that says mean difference at 4. The mean difference at 4. So the mean difference at 4, do you know how they get that mean difference? They just subtract the 6 from the 2. And if you were to write out the t-test formula, and it looks like it is in your book, it looks like section 10.2, the t-test formula is basically the numerator is the mean differences between the two groups, m1 minus m2 if you want, and the denominator, actually, so that's the numerator, the mean difference. So do we want that number to be large or small? We want that number to be large. That number here is 4 because the group mean for one is 6 and the group mean for the other one is 2. And then we need to put that over something that's kind of similar to the standard error of the mean, but for a t-test formula, it's actually called the standard error of the mean difference. And I really don't want to explain that too much to you. The book actually has a little bit on it, but I don't want to go into it very much. But the t-test formula is t equals the mean difference 4 over the standard error of the difference. And so in this case, the mean difference is 4. The standard error of the difference is 0.81. So if you put those into your calculator, put a 4 over a 0.81, what do you think you get? If you put it in, you should get a t-score of 4.899. Now, do you remember what you did in the previous unit with t-scores? You got a t-score, a t obtained. Well, in the last unit it was a z-score, a z obtained, and then you actually compared it looking at a chart to a critical score. Well, I'm happy to actually say that you don't really need to do that anymore. nor do you really need to do this stuff with null and alternative hypothesis so much. All you need to really do here is you need to take the 4 over the 0.81 and get a t-score of 4.899. Look at that column that says sig. That's a wonderful little column, and you want to make sure you annotate what that column is about. Do you see where it has the number 0.008? What that column is telling you is the following. That column is telling you, or that row is telling you, what is the probability of getting your t-score of 4.899 due to chance. And what that column is telling you is that the probability of getting a t-score of 4.899, that the probability of getting that due to chance is 8 out of 1,000, right? 0.008. The probability of getting that t-score of 4.899 is 8 out of 1,000. Is that good news or bad news for us? Hopefully you're going to argue that that's good news. If that number on sig is less than 0.05, you are significant. That's the whole game. So basically, that bottom part of that table gives you a lot of answers. Notice it also says DF of 4. The question is, how do you get degrees of freedom at 4? The way you do that is you say, how many people do you have in group 1? You have 3 people, so how many degrees of freedom there? 2. How many people do you have in group 2? Well, you have 3 there as well. How many degrees of freedom there? 2. So the degrees of freedom, 2 and 2, degrees of freedom are 4. So what you know on the basis of the bottom table is that your t-score is 4.899, and the probability of getting this t-score due to chance is 0.008. And you know this is statistically significant. Hopefully what you learned last week is that we want large t-scores. Remember? If a t-score says 0, that can't possibly be significant. The larger the t-score, the more unlikely this result is due to chance. So in this case, a t-score of 4.899 can happen 8 times out of 1,000 due to chance. That is so low that you say this result is statistically significant. So in this particular case, you've got a significant result. What would your real world result be? Well, you would say that the drug does what? The drug reduces pain. And so in this particular situation, if you follow my bottom example here, the t-test result, we have statistical significance. The real world conclusion is that those people getting the drug, those scores of 1, 2, and 3 are statistically lower than 5, 6, and 7. How do you write this out in APA format? You write T, because that's the formula you used. 4 is the degrees of freedom. You write equals the T obtained, 4.899, and you don't even have to look it up in your book. You write the P equals 0.008. This result is statistically significant and suggests that whatever that drug was, it really did work. So I'm hoping you've written some very, very good notes on this information. And if you are understanding this, that's great. Everything I did the first couple of weeks of the class was really meant for you to understand this. This is useful. Statisticians use this. Psychologists use this all the time. I've done a lot of experiments where I use an independent sample t-test, meaning that I have 2 groups of people and they are both only tested once, and I collect data on one dependent variable, and then I get this data. I tried to use this data set to illustrate a simple example for you. Your homework for this particular one, to show what you may know or you may not know, are examples 2 and 3 here. Let's take a look at example 2 and 3 here. I give you 3 consecutive numbers again, and that should clue you about things like standard deviation, standard error of the mean, and so forth. I give you, in the second example, those getting the drug. So here we go. Those getting the drug, that they get scores of 1, 2, and 3, but those not getting the drug get the score of 2, 3, and 4. So what I want you to do is figure out the group statistics here. See what you can figure out, what you can't figure out. 3 consecutive numbers should give you a lot of key information. Especially you can make some assumptions with example 1 about the standard error of the mean as well as the standard error of the difference score. See if you can compute things, look at the sig there, and see if you can write things up in the proper way. Make statistical and real-world conclusions. So that's example 2. And you might want to even just eyeball those 2 means, because you could probably figure out what's going on there on the basis of that. Next, with example number 3, notice I give you 2 other data sets. The group getting the drug gets a score of 1, 2, 3. The group that doesn't, well, we have a higher a higher baseline, I suppose, of pain, 20, 21, 22. Let's pretend this is like my friend at Jefferson College who was about to go through giving birth. And let's pretend one group, well, just drug and no drug. You can pretend one group got the epidural and the other group didn't, if you know what I mean. So 1, 2, and 3, and 20, 21, and 22. See if you can figure out the means, standard D's, and the rest of this, and figure out if these results would be statistically significant or not. Notice for this one, you may not be able to figure out the exact sig, but you should be able to figure out if something is significant or not. Hopefully that makes sense for you. Thank you very much.